So this webinar will be on the topic of automatic ETL migration. The biggest motivation for changing the integration technologies to move from on-prem to the cloud environments, but there are also other reasons. Everything will be covered during the presentation. So that's me. I am founder of a company called VIS Solutions. We are specializing in data engineering, data analytics, and also robotic process automation. For who doesn't know, these are software robots that emulate data operator work on the computer. But in this webinar, we will mostly talk about data engineering part of our work. This is the agenda. Oh, by the way, if I'm not clear, if you have questions or anything, please feel free to interrupt me at any moment. Marina, you as a host, you can also, if you see the message on the chat, I will be now kind of consumed by the speech. So if I don't see it, please interrupt me personally if there is a chat and read it for me, okay? So this is the agenda. We will talk a little bit about data architectures, about integration technologies, then about the motivation of why would you change integration technology in the first place, then how to do it, and we will cover many use cases, many source and target technologies that can be covered in this case of automatic integration technology migration. At the end, of course, we will cover some benefits, downsides, and have a conclusion. So what is all about? Well, this is a typical architecture that almost every bigger organization has. They have multiple source systems like ERP, that's core business system where you enter the core business transactions and usually have accounting in it. You can theoretically have more ERP systems if you have if one of them doesn't cover all of your business. Then typically there will be some other softwares like CRM, human resources softwares, and so on and so on. So if you want to kind of report from all the sources and analyze the data regardless of the source, you have to integrate them into some way. That's where data engineering comes into place. You will typically integrate all the data in one database that is typically called data warehouse or data lake, but we will cover all the architectures a little bit later. And why do we do it? Well, this is basically the reason. We want to report on the data, make all the reports that we need for the management, for the owners, for the regulators, and so on. Then there is data science, if we want to do some machine learning on the data or statistical methods, but also if we want to analyze data ad hoc on some sort of business request, based on some sort of business request. So when it comes to data integration, we mostly use ETL as a synonym for integration technology as such, but there are many other ways to integrate data. Today is very popular in the cloud, in the time of cloud, ELT, extract, load, transform. Then we have streaming, file ingestions, data pipelines. You will hear many terms for many types of integrating data. But if I say ETL, I mostly mean data integration. So don't get confused. So a little bit about possible data architectures. The oldest one, the one that we probably all know about, is data warehouse. It can be modeled in dimensional way, like Campbell way or Imnon way, more normalized. Once the popular concept was operational data store as well. It's similar to Imnon way, to normalized database with all the data integrated. Nowadays, there are more concepts like data lake, where we dump all the data, structured or not, and then we use it for whatever purpose we want. We have data lakehouse. It's a hybrid architecture that use the best from the both worlds. The structured data is usually in data warehouse structure, and we also have unstructured data and semi-structured data there. Today, very popular is modern data architecture. That's basically cloud data warehouse, but we have many more, like Lambda, data mesh architecture for Internet of Things, and many more. So here is one question for everybody, which is what is the architectures that I tried to show on this picture? Can anybody guess? everybody's shy. So this is supposed to be data lake house, where we use data lake as a staging area for all the data structure from the source systems, but also maybe some sort of streaming from some sensors. And we use data warehouse model for structured data. So we can use both later for data science reporting and so on. Data warehouse is much easier to use, but we also have the possibility to use the unstructured data as well and big data in such architecture. So when it comes to integration technologies, I classified it into three generations. In the old times, often we did stored procedures, especially when data warehouse was on the same technology as a source, because then the clients would save on the ETL tool cost. Then the second generation were like blue chip ETL tools, like Microsoft SQL Server Integration Services, Oracle Data Integrator, IBM Data Stage, Informatica, but there were also some open source and free, more or less free tools like Pentaho and so on. And nowadays, we see a resurrection of the store procedures with ELT concept, where transport part is done in stored procedures, but also we can use modern tools like DBT and so on. Paviljon, and there are many more. So why would we want to change integration technology? Well, one reason is obviously moving to cloud. You have your system on-prem, you want to move to cloud, you will typically need to change the integration technology. But also if your existing technology is like outdated, there are no more new versions, the vendor went bankrupt or whatever, when you want to change the primary vendor, basically political reasons, when you basically think it's cheaper to re-engineer than to maintain the old stuff and so on and so on. So there can be many reasons why companies do it, and they do it nowadays. So how would we do it? We recommend it to do it in 3 steps. First is to migrate the job into new technology in as-is state. Why? Because of testing. We want to make sure that there are no bugs when transforming the job migrating the job to the new technology. And then we can do maybe some technical refactoring if needed, if the job is maybe too complicated, unnecessary, or too slow. And at the end, we would recommend to do the functional refactoring only at the end when we are sure there are no bugs. So if the logic is outdated, then maybe we will have to include business or business analyst to change logic. So when we change ETL technology or integration technology, we have 2 approaches possible. One is manually, of course, that's basically opening the job in the old technology and then programming it from scratch in the new technology. The second approach that we will dive into today is automatic approach. And these are basically technologies, algorithms and procedures for automatically parsing old job and generating the new job in the new technology. I hope everything is clear so far. Please feel free to interrupt me at any moment. So again, when we do it automatically, we have 2 approaches. If we do it one time, we can make an algorithm that will just parse one source technology and then generate the integration jobs in the target technology. But if we want to support more technologies, then we will have to use the meta layer in the middle. So basically it will mean parsing the job in the source technology, storing it into standardized format, and then use this standardized format to generate it in target technology. Why do we do it? Because in such way we can support multiple source technology and multiple target technologies, because all the source technologies are stored in the same format, and all the target technologies use the same format for generating. That's how we actually reduce the complexity of the job, because otherwise it would be square of the number of technologies supported, and now it's more linear, not exponential growth of complexity. I hope you understood this part. The university was a long time ago, but they use this stuff all the time. Okay, so how can we do middle layer? We can do it in some sort of abstract technology under the hood, not visible to users, but our approach is to use Excel as a specification. Excel is basically divided in a couple of sheets. One is select part with target table, target columns, target transformation, from part with all the tables, joins, and sources. We have also the third sheet with where condition and other filters for the job, but there are also maybe some other sheets for like ETL tool, variables, and so on. So how does it work? For example, if we have a data stage as a source, we use XML format of these jobs. Every job has XML definition. We use this file, literally open it, and then the tool, our tool Epic and Genioso automatically parses it and stores it into the meta format we showed on the previous slide. So basically it will generate Excel. And it will do it in just seconds. And on the left side, we see a simple data stage job, but they can be really complicated with a lot of sources, a lot of connectors, a lot of so-called cache files. That's like temporary table, but specific to IBM, so it can be seen in the database. So the complex stuff becomes really simple. You can transfer it, you can parse it in a click. So if you want to migrate such a job to the cloud, we can use this specification to generate the transform part of the integration procedure, because the extract and load will be usually done in this way, as shown in this picture. The source data will be extracted in files such as CSV or XML or JSON files. Then it will be loaded automatically into staging area, and the complex stuff will be done in transform part. And this is the part that we can also automate the generating of it. So if we use store procedure, let's say Snowflake store procedure, we need to have a store procedure template. That's why we can generate store procedures in a technology. And then we select the target technology, select our Excel file. You can maybe see it here. Select target technology, click start, and the store procedures will be automatically generated. As I said, it will be true for any target technology view stored procedures, because we can easily adapt to any syntax using templates. So we can make templates for Snowflake store procedure, for Postgres store procedures, for Oracle store procedure, Microsoft, and so on, so on. So basically, we can, if we use store procedures, we can super easily have many target technologies. But what if we don't migrate? What if we do a development from scratch? Well, how I do it? If I have some sort of target vector dimension table that I need to load, I will typically draft SQL statement to see where can I find all the columns I need, how to join these tables where I found those columns, and not to have any Cartesian product, or maybe filter to strict filter. Then I will do all the transformations from the source format to the target format to see if it's doable. And then typically, if we do it by hand, we have to do the same stuff from scratch, but not in SQL, but in target technology like ODI or whatever. That's why we can also use this tool to just parse our SQL and then generate the target integration job in any technology. So basically, it goes like this. You will again open the file with your SQL stored. You will parse it. And then when we generate the Excel file, you will use the second part of our solution, so-called target generator, where we will open the Excel file, click start, and you will generate the integration job in any supported target technology. Again, we can use store procedures not just as a target, but also as a source, because basically store procedures are just stored SQL statements like merge or insert update with some controlled structures. So basically, our SQL parser can find the smart part, the merge or insert update part, and then process it and again generate our definition in Excel format. We also support some traditional ETL tools on target. For example, ODI, we can select our Excel and generate it just seconds. No scheduled ODI jobs, nothing. It will just generate the target mapping directly into the repository of the ODI in seconds. So it works really well if all Oracle Data Integrator is your integration technology of choice. We can also use ODI as a source, not only as a target technology, because it's basically SQL generator. So we can use just generate SQL as a source. Again, select it, process it, generate our Excel format that we can use a specification for any target technology of our choice. Also, the tool can be used for automating the staging area code, integration code. Staging area is just where we copy the tables from the source systems without any transformation. So regardless if we use store procedures, we can again use templates to generate these procedures. We can use template to generate Python scripts, or we can generate the integration jobs if we use the ETL tool itself, because it will usually, if the complex part, the transform part is supported, then usually the copy-paste part will be easily supported as well. So that's more or less what we can do. Are there any questions before we go to the benefits and minuses and conclusion? Please, anyone? Okay, think about it, and we can also, there will be a section for questions at the end. So which are benefits? Obviously, you will save time moving the integration stuff from one technology to another, because you will automate it. It will be much faster. This will boost your productivity, reduce your costs, and also it will standardize output and enforce some best practices. This is perhaps the most important part, because even when we develop from scratch, I usually, as I said, I usually draft SQL and then use our tool to generate the target stuff, because even if I do it by hand, I can do some unintentional bugs like spelling errors and so on, and this will avoid it completely. Also, the process is kind of self-documenting, because our meta format is in Excel, so you can use it as a standard documentation for like standard documentation on many projects. We use such documentation in Excel with from part, select part, and so on for every table that we load. Minus is initial investment, because you have to procure or develop such a solution for automatic migration. Typically, no solution will cover 100% of jobs, because there are no you cannot cover so many cases that people can think of. And also, if you need to do some refactoring, like functional refactoring, if the logic is outdated, or some technical optimizations, it cannot be done automatically, at least not at this moment. So my conclusion would be like this: if you have a small number of integration jobs, like 1 digit or 2 digits, maybe tens, then do it manually. Don't use time on developing stuff that will migrate just a couple of jobs, because you will probably use more time and money in such a way. But if you have a lot of jobs, like hundreds or even thousands, then in your place, I would try any automation that I can. Well, that's more or less it. Questions, anybody? Was it clear, more or less? I hope somebody is trying to ask me something, but he is muted. Tiago, are you trying to say something? I can't hear you if you're trying. Maybe you can use chat.
I think now you can hear me.
Yes.
Oh, yes. Oh, sorry. Well, thanks a lot, Miljenko, for your presentation. Very interesting, especially the way that you are facing the challenge. Do you use like a specific SQL language for specific database, or do you have any kind of library that makes this like international? I mean, feasible to run using different flavors of databases?
No, we have our own SQL parser that we try to make as general as possible, so it can not only process standard NC SQL, but also we are all the time adding the support for technology specific procedures. For example, if you parse Oracle, then you have some specific Oracle stuff like decode, or I don't know, and we always add this stuff into our parser, so we can transform this stuff into standard stuff. So we basically, if you are familiar with Oracle decode, it's basically a case. So we, if we run into the code in SQL, we will rewrite it as a case statement, so it can be executed on any technology. So basically, yeah, we are trying to parse technology-specific SQL, and then on the target side, always generate NC SQL, because I think it's the easiest for everybody. I hope that was the answer to your question.
Yes, it was. Thank you. Super clear.
Okay. Anybody else? Anything else? Well, if that was it, then thanks everybody for attending. And yeah, we were faster than I thought we will be. So you have maybe time for some sort of break if you have scheduled 1 hour, yeah, for a coffee or something. So thanks everybody.
Thank you. Bye bye.
Bye bye.
Goodbye.
Thank you. Bye.